penguins. And I like penguins too.
And fish.
And we like the Earth. So let's stop emitting greenhouse gases and reduce global warming.
Yay!
Global warming is defined as an increase in the Earth's atmospheric and oceanic temperatures from an increase in greenhouse gases resulting from pollution.
We believe that global warming is true and currently affecting our everyday lives and melting our glaciers and ice caps.
There's proof that the world is heating up, and I'm sure you've heard this many times, but we have proof to back it up.
According to NASA's Goddard Institute for Space Studies, the temperature of the Earth has climbed 1.4 degrees Fahrenheit since recent decades.
Some scientists might say that the temperature has increased and decreased since the world began, but in 650,000 years, the CO2 level has never gone past 300 parts per million. But in less than 50 years, it is estimated to be literally off the charts.
We interviewed Dr. Kathleen Miller from Denver, Colorado, and this is what she has to say about global warming.
This is all for the interview. So the first one is, what is your opinion on global warming? Do you think it's false or fiction?
It is a real phenomenon. Yes, there is global warming going on, and it is surely going to continue because I think it is largely due to greenhouse gases that have been emitted by burning fossil fuels, and that's not slowing down.
Okay, thanks. And one of the other questions was that some scientists say that our world's temperature has been going up and down for as long as you can see. So how can you rebut against that? Because according to the graphs, it really has been going up and down. And even though it only went up 0.5 degrees, the temperature nominally went up 0.5 degrees Celsius, but it's only half a degree. Does that really affect our world?
The tilt of the Earth changes just a little bit over time. Yes, it has gone up and down throughout geologic time, and we have a pretty good understanding of what happen when there's a warming caused by that, what we call orbital forcing, is that there are feedbacks that then start kicking in. And we see that the carbon dioxide goes up when it warms, and so does methane. And one of the questions is, well, why is that happening? Well, part of why that's happening is that there's as it gets warmer, the world gets wetter, and there's a lot more wetlands that as the vegetation rots, it emits methane, and then also as that vegetation rots, it releases carbon dioxide, and so there's that tends to go up in tandem, and it reinforces the warming, and then eventually, as the orbit changes again, that shuts down, and then you see this long cooling trend. And so you see this kind of sawtooth pattern throughout geologic time that is very clearly related to these changes in the Earth's orbit around the Sun. And then also there are periods when there's increased volcanic activity, and sometimes that has an immediate cooling effect because sulfur dioxide is emitted high into the atmosphere, the sulfite aerosols, and that kind of masks some of the incoming solar radiation. But then there can be a more prolonged effect when there's also additional carbon dioxide that's entered the atmosphere, and then there'll be a sort of a warming signal after that. Anyhow, we know a lot about that natural kind of temperature variability. What's different now is that we're increasing carbon dioxide concentrations sort of independently of those natural patterns, and we're increasing it very fast, faster than it's ever been seen in the geologic record. And it's that speed of change, and also right now the carbon dioxide concentration in the atmosphere is the highest it's been in something like 600,000 years, and so 600,000 years ago we were like Neanderthals, in our human history, in our experience, it's never been this high. And so that's one of the reasons for concern. And so that's one of the reasons why scientists are really trying to figure out what's going to happen and how this is going to affect the climate system. And we have pretty good evidence from physics, the basic physics of the way that the carbon dioxide molecule acts with respect to with respect to sunlight, how it's transparent to incoming solar radiation, but it's opaque to outgoing long-wave radiation, so that the heat that is kind of trapped near the surface of the Earth sort of can't get back out as easily, and it's like a blanket that's being put over the Earth.
That in Alaska, Canada, and Russia, those temperatures have risen twice the global average, but basically only in those three places. So how come it doesn't like rise in other places, or did we just get wrong information?
No, your information is correct. Actually, what is expected is that the warming will be fastest in the high latitude areas. So those northern areas. Now, it has warmed elsewhere too. There are only a few spots where it's gotten cooler, and those are due to these changes in circulation patterns. One of the things that happens is that in the wintertime, the storm tracks move north. And so you've actually got more warmth being pulled from the tropics up into the northern latitudes. And so and also sometimes you get a bigger loops in the jet stream. And so sometimes some cold air from the Arctic gets mixed down further south. And so you'll see funny patterns, like remember last winter it was so cold in the eastern U.S., you had all that snow. Well, at the same time, up in northern Canada, northeastern Canada, up around Hudson Bay, it was really warm. It was the warmest they'd seen at that time of year, and the sea ice wasn't forming very fast, and all the natives living up there were getting very worried that they weren't going to be able to go out hunting, because they have to go out on the sea ice to go hunt. They hunt polar bears and other things. And walruses, they go out to the edge of the sea ice to get those things. So they were really worried. And so you had this funny pattern where it was really warm up north and really cold down along the eastern seaboard. Actually, if you go to the NCAR website, now that's where I work, the National Center for Atmospheric Research. You go to our website, you can find all kinds of educational information there about global warming and also these patterns of variability.
To save all the precious animals of our Earth, we need to stop emitting greenhouse gases and make the CO2 levels go back down. Everything gets affected when our ice caps and glaciers melt and when the water rises up. Our polar bears will not have a habitat to live in, and neither will our penguins or our fish, not to mention countless other animals who will lose their home. And without your home, you can't survive.
We have even killed some areas of plant life in the waters, which kills fish. People rely on fish for jobs and food, so without them, we will no longer be able to produce any money or food for our loved ones.
It's like a chain reaction. When one thing is killed, it hurts everything else. If we don't stop emitting greenhouse gases, and if we don't reduce our CO2 level gases, we will all end up in the worst state possible. Anything can help. Just simply recycling your plastic bottles can make us one step closer to saving our population. No, we're going to cut this part out. Oh. And you have to fix what I just said, okay? Okay, what do you mean? Just go.
If we don't start caring more, then we can say goodbye to the world today, because eventually there will be no world. It will all be underwater.
As you can see with this graph, the green star represents where there is a higher pressure, which equals a colder atmosphere, and the purple star represents a lower pressure, which is equal to a warmer atmosphere.
You take both of them.
Take it off. No, definitely not. Take it off.
You guys, can we please put this on our video?
I'm gonna hit you.
Get the camera and